Hello, I'm Haltima Taifa, and this is a lecture presentation for the module Introduction to Smart Grid and Distributed Energy Resources that is part of the MENG Smart Grid program that is offered at the Cape Peninsula University of Technology. In this presentation, the topic we are going to look at is smart electric power from generation to consumption. And we are basically going to focus on um, the application of the concept of the smart grid to various parts of the electric power system. So um, we know that the electric power system has mainly three parts, which are generation, transmission, and distribution. And as I mentioned earlier, we are basically going to be looking at the smart grid in the context of these three main components of the electric power system. In this presentation, we are going to focus on the generation side of the electric power system. And maybe a question to ask is, do we have to consider smartening the power generation part of the electric power system? Basically, is there anything wrong with traditional power generation? So to answer this question, it may help us to briefly look at the history of the electric power system. Specifically, we look at the development of bulk power generation. What are the drivers for the development of bulk power generation? So looking at the history of the development of the electric power system, we find that in the beginning, electricity generation was mainly localized, which means that we had a small scale, a decentralized generation that used to cater for local electricity demand. And what happened was right at the beginning, then the various advantages of electric energy were soon realized, and we started seeing developments whereby the demand for growth of electricity, especially for industrial use, started picking up, and this then promoted generation of electricity in bulk. Then another important development that took place was the technological advancement in steam turbine technology, which enabled the design of large systems which were relatively cheaper compared to the small ones. So this then naturally promoted the setup of large-scale generation stations. Another driver was the availability of large fossil fuels, which are the main fuel that is used in thermal generation. So this again promoted the development of bulk power generation. Then naturally, as the result of this, there was a development of monopolies. Basically, large companies developed electricity supply, generation and supply companies, and in order to consolidate the monopoly, they just grew larger and larger and larger, until we got to a stage where pretty much where we are at the moment, where um, electricity generation and supply is mostly run by very large companies. So all of these factors, starting in the late 19th century and right through the 20th century, were the drivers for the development of this bulk power generation and supply system that we see today. But then there were shortcomings of this bulk power generation. And when we look at all the advantages or the drivers for bulk power generation that we looked at in the previous slide, we find that in the latter part of the 20th century, these advantages were not weighing as much due to other developments that started taking place. So, for example, the economy of scale that that was achieved by building larger and larger generation stations kind of reached a technological cap, which means that there wasn't much of an advantage in making the generation systems larger. Then we had the oil crisis in the 1970s was quite a turning point where people started realizing the importance of the security of energy. Then also the fact that the fossil fuels are finite supplies. They are non-renewable, which means that we can expect that at some point in future we may run out of these fossil fuels. And also the environmental impact of these of fossil fuels, and people started becoming aware of this environmental impact. Then, although the demand growth continued, because of some of these issues that started coming up, getting permits for the development of large-scale power plants became more difficult and required a lot of time from planning to actual delivery. And this means that the expansion of generation would not be able to closely follow the demand growth, and this would obviously create a problem of a balancing a generation or supply and demand. Then we also had a phenomenon that it developed in the latter part of the 20th century, and that was the deregulation or the re-regulation of electricity supply, which started to encourage competitiveness in the generation and supply of electricity. And obviously, this would have implications on how the whole electricity supply chain is run, and this also was had some sort of destabilizing effect on the monopoly. So these are the shortcomings of power generation, and remember that we are talking about smart grid concepts applied to power generation. So obviously, in order to see the the essence or the need for smartening a power generation, we have to look at these shortcomings and how the smart grid concepts can actually assist or can enhance power generation. So again, just to emphasize the shortcomings of power generation, the primary energy source are fossil fuels. Um, as I have highlighted, there are a number of aspects that or a number of issues associated with the fossil fuels. The environmental impact is one. There's obviously the cost, efficiency, which is a quite an important consideration, especially when we consider the fact that typically um, a power generation that is based on fossil fuels has got an average efficiency of 30%, which means that from the primary energy source, only 30% of the actual energy is converted into a usable electrical energy. So that is a very important consideration. It does affect other aspects such as cost, environmental impact, as well as the finiteness of the resource. Then flexibility is also an important consideration when it comes to power generation. One of the most important characteristics of power generation is that generation has to follow demand. So things like the size is important, as well as the location. Most of the bulk power generation that we have today is located very far from load centers, and the one reason is that a bulk power generation firstly has to be located close to where the resource is, and secondly, because of the pollution, especially the fossil fuel based power generation, it cannot be located very close to residential areas. So there is the aspect of a locational constraint which brings about other issues as well. Then the fact that it's far from the load center means that there is a necessity for long distance transmission, which also is associated with its own issues. So this is just really a sample of some of the issues or the shortcomings of bulk power generation that should cause us to, to consider what enhancements are possible in the power generation sector in the framework of the smart grid. Okay, so we are going to look at one way that we can address these shortcomings of power generation, and that is by means of a distributed power generation. So as these issues with power generation started surfacing, then we saw another development, and this was a very a keen interest in distributed generation. And what are the drivers for the development of distributed generation? This is what we're going to look at in the next few slides. So firstly, the need for primary energy source diversification. As I mentioned earlier, some of the shortcomings of a fossil fuel-based power generation is the finiteness, as well as the scarcity of the resource, and the fact that it is a constraint geographically to be located only in certain places, which means that those who do not have large deposits of coal or oil resources are dependent on sourcing this from those who have. And this brings up the issue of energy security and dependency. Then the need to reduce the environmental impact of fossil fuel-based electricity generation, um, the need to reduce long-distance power transmission, which is associated with technical and economic issues. Then also the need to be able to supply electrical energy to remote areas where the main grid cannot reach for technical or economic reasons, and the need for generation flexibility in terms of the location, the size, as well as the operation. So if we look at all these drivers for distributed generation, what we find is really the shortcomings of bulk power generation became the drivers for the development of distributed generation. And when we look at eh, those who advocate a distributed generation, such as renewable energy and other forms of distributed generation, these are the commonly highlighted drivers for the development of distributed generation. So the phenomenon that we witness presently is an electric power that is transitioning from the one that is characterized by large-scale centralized generation to one that is more decentralized. And I can highlight here some of the main characteristics of the modern or the future electric power system, and that is extensive deployment of a distributed generation, energy storage, as well as other forms of distributed energy resources, as well as other characteristics that we see in development today. So what we find is that distributed generation is considered to form a very important component of the future electric power system. And as we see in this in this diagram here, at least at the moment, centralized power generation is certainly going to be a part of the electric power system for a very long time to come, because distributed generation alone cannot really completely replace centralized power generation. But definitely there is no doubt that there is a drive towards distributed generation having a much a greater contribution to the overall supply of electricity. So with these developments, the picture here shows us kind of the current state of affairs, where we have electricity that is mainly based on fossil fuels. We can see what impact it has on the environment, and what is envisaged for the future is the replacement of this current state by a future state which is much more environmentally friendly, as well as sustainable. So just to over the previous few slides, we have been looking at the developments in the power generation sector, starting with the history of the development of the electric power system, the drivers for the development of power generation, shortcomings, and how these shortcomings are being addressed by the development of distributed generation. So now we are going to look at a couple of definitions that are related to distributed generation. This may be familiar to some of you, but for some people, distributed generation is a whole new field, and it is obviously useful for us to just have an idea of what the experts say about what distributed generation is. Obviously, when you look at the literature in the field, you find a variety of perspectives and definitions. These definitions that I have here are based on a publication from 2002. So there may be some changes to some of these definitions, but really the core concept remains the same, and to a very large extent these definitions are valid even today. So when we look at distributed generation, we are, according to this publication, the International Energy Agency considers distributed generation to be generating plant that is normally connected to distribution level and is mainly for the purpose of serving customer needs. Some of the technologies, we have a variety of engines, fuel cells, photovoltaic, and according to this definition, a large-scale wind power generation is excluded from this because it's that is usually connected to the high voltage system. Then we've got a definition for dispersed generation. So this is just distributed generation plus wind power. According to the IEA, this now forms a dispersed generation. Distributed power is distributed generation plus energy storage. Then we have distributed energy resources, which now combine all forms of distributed generation as well as a demand side measures. Decentralized power, again, these definitions are really very much related. You may say that they are talking about pretty much the same thing. So, but it is a good idea just to know that there are these different definitions and how they classify the various aspects of distributed energy resources. So looking a bit more into distributed energy resources, so these DERs are considered to consist of distributed generation, energy storage, as well as a controllable load or a demand response. So a resource in the context of power generation is anything really that can supply power or flexibility. So in terms of distributed generation, that can actually supply generation, and controllable load can supply flexibility, in the sense that in the case where we have insufficient generation, we can implement a demand response, which is basically a measure to reduce demand in order to achieve a generation and demand balance. So, and looking further into distributed generation technologies, what we find is there is a variety of technologies, and these technologies differ in terms of the primary energy source and the size, as well as the application. So the diagram that we see here, it tries to classify the various distributed generation technologies in terms of the primary energy source, in terms of size, as well as in terms of application. So what I can highlight here is um, sometimes we may think that distributed generation is only renewable, but actually there are some fossil fuel based distribute electricity generation systems that are classified under distributed generation. Um, so it is I can encourage you to spend some time looking at this diagram just to familiarize yourself with various technologies. Um, then the sizes, so we can see sizes range from hundreds of watts right up to hundreds of megawatts. The applications can be domestic, commercial, it can be industrial, as well as grid. So you will see that there's actually a correlation between the primary energy source as well as the application and also uh, the size. So for example, on the on the larger scale of the size, these the application is limited to industrial and grid application. It is not very common to find tens of megawatts of a generation that is meant to supply a domestic needs. And also when we look at the primary energy sources, we find technologies such as a conventional a gas turbine. This is mostly for industrial, even a grid applications in certain cases. Okay, so these are the distributed generation technologies. Obviously, this is just a sample of them. You can find a lot more in the literature. Then another important distributed energy resource is energy storage. So there is a variety of energy storage technologies. Here we can also classify them in terms of the, um, the, the, the primary form of a storage. So we have mechanical energy storage. Examples of these are pumped hydro, flywheel, and compressed air. Then we've got chemical energy storage, chemical, electrical, as well as thermal. In terms of application, we find that the most commonly used is electrochemical, um, mainly secondary batteries, and these have got a wide range of applications from domestic, commercial, even industrial and grid. So energy storage, as we discussed in the previous topic, is considered to be a very a key component of the future smart grid because of the various positive characteristics that it is expected to contribute to the achievement of the smart grid objectives. Okay, so question that we can ask is what does smart power generation really mean? What would we like to achieve, or what enhancements do we envisage for power generation? Okay. So again here really this is related to the shortcomings of a bulk power generation. Ideally we want to improve the conversion efficiency of a power generation because this does affect a lot of things such as the cost to the utility as well as the cost to the end consumer. There is also an environmental cost and many other factors. Proximity to load. This is a very desirable characteristic of power generation. The closer it is to the load, the greater the efficiency. Then flexibility is important in terms of the location, the size, as well as the operation. Security of the primary resources is very important, as well as the sustainability, environmental sustainability, social and economic sustainability. These are very important issues that have to be considered in terms of power generation. So what we can say here, or what is claimed, is that the efficient use of distributed energy resources is envisaged to have a significant positive impact on these desirable characteristics of power generation. So those who advocate distributed generation do so on the basis of the enhancement of the efficiency, flexibility, security, as well as the sustainability of electric power supply. Okay, now the next thing that we are going to look at is the integration of distributed energy resources into the electricity grid. And why do we have to consider this topic? It is an important aspect in terms of realizing all the benefits of the distributed energy resources. And we have to consider what are the characteristics of distributed energy resources. What we find is that when we look at the characteristics of distributed energy resources, firstly, it is non-conventional compared to traditional power generation. Non-conventional in terms of the operational dynamics that are significantly different from conventional thermal-based power generation. So we can highlight here the concept of inertia. I do not know how many of you are familiar with this concept, but inertia is a very important characteristic that affects the operational dynamics of the electric power system. And all I can say here is that most distributed energy resources do not have the inertia that we find in the traditional power generation, and that obviously does affect the operational dynamics. Then we can highlight also the aspects of the variability. And most renewable-based power generation is variable because it is dependent on weather conditions, which are variable in nature. Then predictability is also an important aspect. So again, renewable-based generation, which is dependent on weather conditions, does not have very good predictability, and that also affects the controllability. So when we look at the characteristics of distributed energy resources, we find that these are some of the very important aspects that we have to consider. And because of this, we find that the integration of distributed energy resources into the grid is actually not it's not a plug and play situation, and it is not a trivial issue, especially when we really want to realize the full benefits of electric power generation from distributed energy resources. So what we are going to look at in the next few slides is the approaches that are commonly used to efficiently integrate distributed energy resources into the power system. And I am going to talk about two main ones that you will also find very extensively discussed in the literature. And these are the microgrid as well as a virtual power plant. Okay, so starting with the microgrid, you will probably find a variety of definitions for a microgrid in the literature, but basically a microgrid, we can really consider it to be a miniature electric network, a self-contained electric network, which is going to have basically it squeezes everything that we find in the large-scale power system into one small a scaled down version of the large electric power system, which means that it is supposed to have generation systems, it is supposed to have a distribution network as well as loads. Okay, so a microgrid is characterized as an electricity network that is comprised of distributed energy resources, and as I have mentioned already, distributed energy resources have got distributed generation, energy storage, as well as controllable loads. Then a microgrid also has an uncontrollable local load, and it is normally considered to be connected to the low voltage or medium voltage distribution network. The main characteristics of a microgrid or the basis for its development, we have the concept of aggregation. So we try to aggregate a variety of resources to try and optimize the utilization of these resources. And also there is a lot of emphasis on improving the reliability of supply by having operational flexibility. And the next slide is going to bring out further that component. So a microgrid is normally connected to the main grid. Okay, so what we see in this picture here is we've got the main grid, which is represented by this this part. So this would represent the whole distribution network. Then on this side, we've got the microgrid. As you can see, as I mentioned in the previous slide, a microgrid is going to have a variety of distributed energy resources. We've got PV here, we've got a micro turbine, we've got a fuel cell, and some energy storage. Then what is not really brought out in this depiction are the loads, but we do have loads as well. So a microgrid is connected to the distribution network, and very often in the literature you will hear of a talk of a point of common coupling. So this is the point at which the microgrid is connected to the distribution network, and the flexibility that has been talked about in the previous slide basically means that the microgrid is meant to be able to operate both you know, in parallel to the distribution network as well as independent of the distribution network. And the flexibility basically comes in where um, what we find is that we've got experience already here in South Africa with this problem of load shedding um, when when the supplier, the electricity supplier, is not able to keep electricity supply 100%. So the availability of the microgrid basically gives us the opportunity to continue supplying critical loads in the absence of grid supply. So that is one of the main motivating factors for the development of microgrids, or to try and improve reliability of supply, especially for certain mission and critical loads. Okay, so that is just a brief overview of what a microgrid is all about. Obviously, there is a lot more to talk about when it comes to the microgrid. Here is just to highlight the concept of the microgrid, what it is, what are its components, and what are the main what is the main purpose for the development of the microgrid. Then a virtual power plant. This is also another a key concept or an important approach for the grid integration of distributed energy resources. A virtual power plant, or a VPP, also tries to aggregate a variety of distributed energy resources, and the main purpose or the main goal for a virtual power plant is to basically come up with a system, an aggregated portfolio of distributed energy resources that are meant to operate together so that they actually resemble a conventional power plant. Okay. So a virtual power plant basically makes use of advanced information and communications technologies to set up a portfolio of coordinated resources that are spread throughout the electricity network, and it creates a portfolio that would actually resemble the operation of a conventional power plant. What are the key components? Distributed energy resources, advanced information and communications infrastructure, energy management system, as well as an advanced monitoring control system. So, as mentioned, the main objectives of a virtual power plant are to enhance the characteristics of distributed energy resources. Now, if you remember in a previous slide where I talked about the characteristics of distributed energy resources, I did mention the aspect of controllability as well as predictability and variability. So most distributed energy resources lack controllability on their own. And by aggregating a variety of distributed energy resources, each of which has its own unique characteristics, we find that we can actually improve the the controllability and flexibility of these systems when they are aggregated together. Okay, and the idea is that when we improve the controllability as well as the flexibility and visibility of the systems, we actually enable the participation of the DERs in the electricity markets, as well as the provision of ancillary services by the distributed energy resources. Now, unfortunately, I cannot not go into details of these aspects, but these are very important concepts when it comes to the modern electricity grid, as well as the smart grid. I know that in one of the modules that you are still going to do, you are going to look into electricity markets into more details. This is quite an important aspect in the electricity industry, especially in the context of the deregulation of the electricity, as well as the ancillary services. Okay, so there is uh, it is one of the important considerations of when it comes to distributed energy resources that we should be able to incorporate these into electricity markets, as well as be able to provide ancillary services from these DERs. So, as I mentioned earlier, a VPP really is an attempt to create a single a portfolio or operating profile for a variety of distributed energy resources, um, which would then enable the VPP to actually operate as a conventional power plant. Obviously, there are some technical limitations to this, but really the idea is that we end up with a system that can be characterized by a set of parameters that are usually associated with a transmission connected generation, and this would then enable the efficient integration of DRs into the electric grid. Now, we have talked about these two approaches to the grid integration of DRs into the grid integration of DRs. Now, a question that we may want to ask is there any difference, or what are the similarities and what are the differences between a microgrid and a virtual power plant? Obviously, the common objective of these two is to realize the efficient grid integration of the distributed energy resources. So that is the underlying primary objective that is shared by both of them. However, we also find that there are some differences in other objectives. So the main focus of the microgrid is to enable basically, I mentioned earlier, to improve supply reliability. So a microgrid is able to operate in conjunction with the grid, as well as independently of the grid, and it is mainly focused on meeting local demand and to improve the reliability of supply of electricity to the local demand, almost independently of the grid. When it comes to a VPP, the main focus is on the efficient integration of the Rs into the grid to enable them to have a greater contribution to the whole electric grid. So I hope you can actually distinguish between those two primary focuses. A microgrid is, we can say, it's more localized. It is more concerned about meeting local demand, and a virtual power plant is more concerned about more efficiently integrating DRs into the grid, so that we really cannot distinguish between a conventional large-scale a traditional power plant and an aggregation of a distributed energy resources. Okay, so that is an important a differentiating factor between the two. Then we also have the locality aspect. Again, a microgrid is geographically confined. It's mostly local, whereas a virtual power plant, because it makes use of advanced information and communications technologies, it is not confined in terms of geography, because it aggregates resources, distributed energy resources that are spread over a wide geographical region. Obviously, there is a limitation to this also, but it is still a kind of a differentiating factor between a microgrid and the VP. Infrastructural needs. A microgrid does not have as much a need for advanced ICT infrastructure, whereas a VPP really, for a VPP, ICT infrastructure really forms we can say the backbone of this VPP, because it is mostly focused on the aggregation of a variety of distributed energy resources. It requires a very extensive and advanced ICT infrastructure, and this obviously does affect the cost aspect of this system. Okay, so this basically brings us to the end of this presentation. In this presentation we have been talking about the smart grid concepts in the context of power generation. I started by looking at traditional power generation, how it developed, the shortcomings that triggered interest in the development of distributed generation. And if you look at the points that I have presented here, you will see that there are a lot of aspects of distributed generation that really embody the many objectives of the smart grid, such as efficiency, sustainability, affordability, and many other positive characteristics that we wish to impart into the electric power system in the framework of the smart grid. So thank you very much. The next we are going to carry on in the next presentation on looking at the application or the various concepts of the smart grid in terms of power generation, transmission, and distribution and consumption. And in the next presentation, we are going to be focusing on on electricity transmission and distribution. Thank you.